All right, here are our last notes for chapter 9. So now we're going to be graphing linear inequalities. So a linear inequality with two variables is an equality that can be written in one of these forms. So it can be ax plus by is greater than c, and it could also be greater than or equal to, or ax plus by is less than c. So it could be greater than or equal to and less than or equal to at the same time. In other words, it's a linear equation that has an inequality symbol to it. So a solution, just like when we did lines, when we reviewed those, is a point, x comma y, such that if you replace the x and the y into your inequality, you're going to get a statement that is true, just like it was for a linear equation. So we're back to graphing lines. So so here's what you do. Here are the steps that you do. Graph the boundary line. Now it's going to be dashed if it's less than or greater than, and it will be solid if it's less than or equal to and greater than or equal to. So here you don't want to include the line, so you make it dashed. Here you do want to include the line, so you're going to make it equal to. Choose a point that's not on the boundary as a test point. Substitute that in. If the test point is a solution, so if you get a true statement, then you shade on that side of the line. If it is not a solution, in other words, you get a false statement, then you shade on the opposite side of the line. So here we go. Now we know many ways to graph a line. First of all, why don't we go ahead and let's put this in slope-intercept form, because there's one way. So in other words, I'm going to subtract x. I'm going to review all ways to graph a line with you. So that's going to be y is less than negative x plus 5. So if you're going to graph a line from slope-intercept form, we're going to graph the boundary line now. You go to the y-intercept first, 1, 2, 3, 4, 5. And then remember, you use rise over run for slope. Since my slope is negative 1 over 1, I'm going to rise down 1 and to the right 1. Down 1 and to the right 1. So now, is it going to be solid or dashed? Well, because there is no equal to, it means it's going to be a dashed line. So dash your line. And now you have to decide, where am I going to shade? Am I going to shade on this side of the line, or am I going to shade on this side of the line? Well, here's what you do. You pick a test point. It can be any point as long as that point doesn't lie on the line. My favorite test point is 0, 0. So how am I going to figure out where to shade? Well, I'm going to take my test point and I'm going to plug it into, by the way, it can be plugged into here or into here. It doesn't matter. I'm going to plug it into here. So if I plug 0 in for x and 0 in for y, I get 0 is less than 5. Is that true or false? That is true. What that means is that this point is a part of my solution set, which means I'm going to shade on the side of the line where that point is. If you plug in your test point and you get a false statement, that means all your solutions are on the other side of the line. Now, let me review another way to graph a line. Now, you could go ahead and you could put this in slope-intercept form and go ahead and do it just the way we did the first example. It does not matter. But do you remember from 53, another way to graph a line is to find the intercepts, the x-intercept and the y-intercept. Let me review it with you. So the x-intercept is a point where the y is equal to 0, and the y-intercept is the point where the x is equal to 0. So if I go into my inequality and if I plug 0 in for y, do you see where that would be 4 times 0, so that would be 0. It would disappear, and I would get x is equal to 4. That is the x-intercept of the line. It crosses the x-axis at 4, 0. To find the y-intercept, I plug 0 in for x. Well, if I plug 0 in for x, that disappears. And if I solve that for y, I'm going to get, when I divide both sides by 4, I'm going to get 1. Once you find the x-intercept and the y-intercept, you can just go ahead and you can plot those points. There's 4, 0, and there's 0, 1. And now I'm going to graph the line that passes through those 2 points. So first of all, because there's an equal to, it's not going to be dashed, it's going to be solid. So I'm going to go ahead and I'm going to graph it as a solid line. And again, I'll say it, if you want to take time and put this into slope-intercept form and graph it the same way we did our first example, you're going to get the exact same line. Now we have to decide where to shade. Well, again, 0, 0 is a really nice test point. So I'm going to go to my inequality, I'm going to plug 0 in for x and 0 in for y. Well, this says 0 is greater than or equal to 4. That's false. So that means that this is not the correct side of the line. This is not part of the solution, which means you shade the other side of the line. Okay, let's look at this line. Now this one is interesting. And here's the deal. You cannot find the x and the y-intercept of this line. And here's why. If I find the x-intercept, well, I should rephrase that. You can. It's just not going to help you graph. Let me show you why. If I find the x-intercept by plugging 0 in for y, do you see where I would get an x-intercept of 0? And if I find the y-intercept by plugging 0 in for x, so 0 is equal to negative 2y, do you see where I also get 0? In this case, since there's no c, by the way, both intercepts are 0, 0. That's great. It goes through the origin, but it doesn't give me another point that I need to help me graph. So I'm going to have to put this one in slope-intercept form. So first thing I'm going to do is I'm going to flip-flop this so my y is on the left-hand side. Now when I do that, notice how the symbol is pointing to the y. When I flip it, it's got to still be pointing to the y. These two inequalities mean exactly the same thing. But now to get this into slope-intercept form, I have to divide both sides by negative 2. Don't forget, when you divide by a negative number, it flips the sign. And that side is going to turn out to be negative 1/2 x. So now look, there's really a plus 0 there, so the y-intercept is 0. We already knew that. But since the slope is negative 1 over 2, I'm going to go down 1 to the right 2, down 1 to the right 2. So now you can see that line. By the way, you could get it this way and make a chart if you want. That's always an option as well. Totally up to you. Because there's no equal to, it's going to be dashed. And now the bummer thing about this, remember, I have to pick a test point. My favorite test point is 0, 0. I can't use that because the boundary line goes through 0, 0. I have to take another point. Doesn't matter. I'm going to choose this point right here. What is that point? 0, 3. That's going to be my test point. So, again, I can plug it into here, or I can plug it into here. It does not matter. I'm going to go ahead and plug it into here. So if I plug 0 in for x and 3 in for y, because remember my test point is x equals 0, y equals 3, it says 0 is greater than negative 6. Well, hot dog, that's true. So that means this is part of the solution. I'm going to go ahead and I'm going to shade that side of the line. Now remember, there's a couple of special types of lines. Look at this one. It's missing the X. So one way I taught you to graph these, or I reminded you to graph these, is remembering if I'm graphing the boundary line, which is y equals -3, that means y is always -3. X can be anything. So 0, -3, 1, -3, 2, -3. Or you can just memorize that if it's missing the X and it's a y equals, it's a horizontal line. It's going to be solid because of the equal to. So there's the line, the boundary line, y equals -3. So now you can't pick a test point for a horizontal line or a vertical line, because every point will have an X and a Y, but you're missing one of those. So you just have to use logic. Think about it. Greater than or equal to. If I want to be greater than a horizontal line, hopefully logically that tells you that you're going to shade above the line. If I wanted to be less than a horizontal line, it would be below. I guess I can go back and also mention that if it was a vertical line, like if you had a vertical line as your boundary line, do you see that this side would be greater than to the right, and then this side would be less than to the left? So use logic. All right, last example in chapter 9 here. So what if we talk about a system of linear equations? Now we're going to do systems of equations, maybe next chapter, but this is a system of lines. All that means is you graph each of the inequalities separately, but on the same set of axes. And the solution is where your shadings overlap. Where does my shading overlap? So we're going to graph 2x minus y is less than 0, and we're going to graph 5x plus y is greater than 5. And we're going to graph them both on the same graph. So, and again, you can graph them using x and y intercept. You can graph them using slope-intercept form. Let's go ahead and let's put this one in slope-intercept form, which means I'd first subtract 2x. So that would be -y is less than -2x. I would have to multiply through by -1, and don't forget what that does. That flips the symbol. And now just for practice, why don't we go ahead and let's find the x-intercept and the y-intercept for this one, just so you can see once again both methods. So remember, for the x-intercept, you plug 0 in for y. And for the y-intercept, you plug 0 in for x. So if I plug 0 in for y, that y will disappear. And when I solve for x, I'm going to get 1. For the y-intercept, if I plug 0 in for x, 0 times 5 is 0, so that term disappears. And you can see I'm going to get a y of 5. All right, so let's graph them one at a time. So here we go. What's the y-intercept here? Since it's in slope-intercept form, the y-intercept is 0. So darn, I'm not going to be able to use 0. 0 is a test point. My slope is 2 over 1, so I'm going to rise up 2 and to the right 1. Up 2 to the right 1. That is going to be a dashed line. I have to figure out where to shade. So I'm going to go and pick a different test point other than 0, 0. So I'm going to pick this test point right here. That test point is 4, 0. And I'm going to go ahead and I'm going to plug it into here and see if it works. So y is 0 is greater than 2 times x is 4. It says 0 is greater than 8. Yeah, that is not true. So that means I'm not going to shade this side of the line where 4, 0 is. I'm going to shade this side of the line. I'm going to do that kind of lightly because remember my solution is where do the shadings overlap for both of them? Because I'm only halfway done. Now I have to go ahead and I have to graph this inequality. Well, I already did the work. My x-intercept is at 1, 0. I'm going to erase my test point there. My x-intercept is at 1, 0. And my y-intercept is at 0, 1, 2, 3, 4, 5. So it goes through these 2 points. It's again a dashed line. I'm going to do this one in my green pen, actually. You can use colored pencils, whatever you want to do. So here's my line. It's in green. I can pick 0, 0 for my test point for this line because that line does not go through 0, 0. So if I go to my equation or my inequality and if I plug 0 in for x and 0 in for y, it says 0 is greater than 5, which is not true. So let's see what I have. So that means if I'm looking at this line, 0, 0 is not part of the solution, which means I'm going to shade the other part of the line. So at this point, let's just shade where the 2 shadings overlap. Do you see where they overlap right in here? Because remember, if this is my green line, kind of right here, I would shade not on the side with 0, 0, I would shade on the other side. So I would shade all the way up here, but the overlap is going to be this area right here. And there you go.